Welcome. This is going to be the first session on IoT. The next session is going to be Bartek. He's going to continue a session, and we're going to do some bits together. So if you want to stick around for the session after this one, you're going to see amazing demos. So yeah, this is IoT. So does everybody know who the Borg people are? Right, the ones that are like robots and everything like that. So can you imagine that in a few years' time we're all going to be a bit robots, you know, with this thing on your ear or something like that? Right? So chips implanted into your brain, and all the information just shows up in your eyes like science fiction, right? So that's probably going to happen sooner than we expect, and that has all to do with IoT. So everything is going to be interconnected. Everything is going to be helping us out in some way. So the point of IoT is not to make us robots. The point of IoT is to help us do our tasks more efficiently. So, first of all, this is very important, so thank you to our sponsors. We have an amazing number of sponsors. Have you seen it? It's like almost 20 or something like that. It's probably the most amount of sponsors I've seen in an event. This is amazing. And this event is very big. You know, like you guys see, it's huge. Right, so it's a very big event, and this event is only possible thanks to these guys. So do see, you know, their stands and everything they have to offer, which is important. Okay, so who am I? I'm this guy, and that is a true picture. That's not Photoshop. Well, the background is, but the guy was in front of me. So I'm a Microsoft certified trainer doing consulting, doing training, mostly in Azure and SQL Server. So I'm kind of in an area you probably are. So doing development, doing consulting, doing data stuff. And I also do something a bit different, which is I also do electronics. So my background is in electronics. That's the stuff I've been doing all my life because it's fun, not because it's work, just because it's fun. And currently, when you have IoT, mixing, you know, data and you know, programming and electronics all together makes perfect sense, and it's very fun to do. Okay, if you want to contact me, here are my contacts. Just go to md.pt, best website you've ever seen, like a single page, but it's great. And yeah, and that's my company, and that's my company's logo, which is cat's paw. So cats also do IoT, they destroy it. Okay, so they're the testers. We should call them the testers. Okay, so you might not know this, but I am from Portugal, so I had to fly here. And to fly here, there is a problem, which every time you go to an airport, people just frisk you. So I decided not to bring, you know, any hardware equipment like a Raspberry Pi or an Arduino board or something like that. And the thing is, most IoT sessions that you see, both in videos and personally, they spend an hour trying to get everything done, and in the end, the thing that happens is a LED blinks. So let's solve this problem immediately. The LED is blinking, so that demo's done, right? So let's move on and do better stuff. Okay, so Internet of Things, not very old, the concept, right? So someone came up with this, you know, 10, 15 years ago, something like that. And it's not really a technology. It's not really a protocol. It's not something that you say, oh, that's it. It's just a concept, okay? So it's the concept of doing certain things we're going to talk about in a second. And I was actually very surprised to figure out it resembles kind of a lot like, you know, the Borg people, because after a while they're going to be assimilated into all of that. So it's actually scary to think about that, but that is going to happen. Okay, so a funny cat, because every presentation needs to have a cat, right? And yes, hopefully you will enjoy the session and the sessions afterwards. Okay. So let's get started with this, but before I do, I'm actually curious. How many of you guys are developers? You know, programming, normal programming stuff. Yeah, okay. You can be more than one when you raise your hand. So how many of you are DBAs? And you do SQL stuff? Okay. How many of you guys are, you know, system administrators? None. Oh, one. Good. We have one system administrator. Lawyers? Okay, so if you had one, we would have to get rid of it, so it's okay. So that's fine, that's fine. I have a great lawyer joke, but I'm not going to tell it now. It's been filmed, so not a good idea. So let's talk about IoT. This is my definition. It is not any official definition because there isn't any. So my official definition has a few points. So for an IoT solution to exist, for me, it has to have certain things. So one of the things is it has to be connected somewhere, right? Because it needs to be connected. So you can connect it, the typical one is Ethernet cable, wireless, a cell phone kind of connection. And then you have the ones that some people, I'm not sure, any of you guys do electronics? I did forget to ask. One or two, okay. So I'm not sure if you know about this, I2C, SPI, RF. So RF is just radio things, Bluetooth not much different. I2C and SPI are two protocols that you have certain number of cables and they connect between two devices. So that's actually one of the most typical ways you can connect devices. And obviously the other one is actually works. Take a look at it. I'm not going to tell you about it, but take a look at it. Okay, so. And these devices are all connected, but they have to be connected somewhere. So two options. You either connect them all together, like a network without being centralized somewhere, or you just centralize it. And you don't have to centralize it in the cloud necessarily, okay? Despite that saying it's Internet of Things, you don't have to centralize it in the cloud. You've had situations where you had IoT for a long time, and the simplest one is, fire alarm and intrusion detection and stuff like that. Technically, that would be IoT, okay? Because that complies with all the points that I'm making here, and it's still not connected to the internet. So you can see the internet is not a part of the concept. Okay. Then what do you need to do? And this makes perfect sense because they are sensors, they are devices, they need to sense something. If they're devices just to be devices, it doesn't make any sense. So they have to sense something like temperature, they have to sense stuff like this. If there's too much light, too little light. So not enough light, that's okay, we'll turn on the lights in the ceiling, no problem. If it's too hot, we'll turn on the air conditioning automatically. So it has to sense something. And obviously one of the most important things it can sense is our interaction. So we can have buttons for us to communicate with the device. Buttons or anything else. It can be a voice activated thing, right? Okay, and then it should accept some commands. It should do something, okay? It should receive information via the buttons, for instance, or via, communication that it receives and is going to do something. Typical things. So he received information that it's too hot, he needs to turn on the air conditioning. He can move that robot arm and do something. He can open a garage door. He can do whatever he wants. So one of the things it should do, it's not mandatory, but in most cases should do, is to allow to do some sort of action. Okay. Although there are some that just have sensors and that's all they do, they measure stuff, which is okay, but this one is very much the spirit of IoT. Okay, and finally it has to interact with the user, because in a way, even if it spends like a year getting information, by the end of it, that information has to go to the user. Because the computer doesn't need it, we need it, okay? So it has to go to the user somehow, and then one of the things that you can do is you have the device there, you have information like a screen or some lights or something like that, and that informs you of that. And indirectly you can have any type of web thing, like you can actually use Power BI, like we're going to see afterwards, and you can use any way to connect it, like emails or something like that, the usual stuff that you used to when you use the internet, okay? So that's my small idea of what IoT should be. Okay, so just to tell you what has happened. So the first time I did this presentation, slightly different, but this presentation, the arrow was over there. So this was about a year ago, and this was on 25,000 million. Okay, and now we're over here, and it's 32,000 million. Okay, so 7,000 million devices more in just 1 year. Okay, and when I started, programming seriously, like in the early 90s, it was only 1,000, but those 1,000 things were not IoT devices. They were just plain computers connected eventually to the internet. Okay, so you can see most of these are cell phones, but nowadays you have much more stuff. Okay, and obviously if you get to 50 billion, you get one of those square spaceships. Okay, so it's a bonus. Okay, it's like a game, it's a bonus. Okay, so I usually ask this question. If you already know the answer because you've seen this session before, please don't say it. So the question is, what do you think is the first IoT device according to the rules that I mentioned? Can just telephone. Telephone is a good idea, although telephone is a bit limited. But it's good. It's good. Telephone is good. First? Oh yeah, okay. Still same area things. Okay. I'm gonna try to suggest one thing, but the phone is good because it was over 100 years ago and it served some purpose. But the phone, I would say the only actuator that it worked on was the bell. Small connector with modem. Okay, that's good. Maybe 80s, late 70s, 80s, something like that. Okay, that is good as well because you can do stuff with it. Yes, that's good because you have the connection stuff well prepared, and then you have an intelligent CPU to do stuff that you can program. So that is very good. Okay, so I thought about this a lot, and I figured out that the first one is the nuclear launch red button that the president, hopefully not the current one, but yeah, the current one has one as well, that he has on his desk, and if he just does this, he's going to blow up the whole world, right? Because the missiles launch. Fortunately, it doesn't happen like that. He presses the button, there's some guy receives a phone call and says, oh, he wants to launch the missiles. Okay, he's crazy. Yes, we know, but we have to press the button as well. So what we do? Okay, so fortunately there are intelligent people that don't care about that person, but still, this is around since maybe the 1950s, something like that. I can't tell you the exact dates, but I think this is a good start. So it has everything. It has communication because it communicates to somewhere where you have the missiles, right? And it informs you back because it has like a monitor or something that says missiles were launched, missiles reached target. So it has sensor somewhere else that sends the information back, and the guy is sitting at the desk and he's looking at it and he understands what happened after he pressed the button. So it's kind of one of those. But for me, the most interesting one is not that. It's something you probably never thought about because, this is before the internet. It's before the internet. You had phones at the time, makes sense, but it's before the internet. But the other one is also before the internet, and it's, space exploration. Okay? So I'm not sure how many sensors there are in, the International Space Station or any other place, if you think about it, but it's thousands, okay? Many thousands of sensors, and they're all connected down here to Earth, and they can understand what's going on in all those sensors, and they send information back so that the space station, if the people are dying or something, they don't have to do anything, and that actually changes the air flow and all that stuff, air conditioning, all that stuff that they need to. So you can do all of that remotely. So that is amazing. And that is the spirit of IoT as well. So many more. One of these is the most typical one you've seen maybe since the 80s, something like that, which is domotics, which they call domotics. And basically what you do is you have a lot of sensors that tell you it's too bright, it's too dark, let's change something, let's turn on the air conditioning, TV. If I go into a room, everything lights up. So this is not new. This is maybe the 80s they started experimenting on this. So if you are really a fan of electronics like me, in the 90s you had tried something like this before. Maybe not as advanced like centralized this on the cloud or something like that, but you had done something like this before. Okay, so I asked what you guys did because I have a graph here that's going to show you what you can do with IoT. Okay, so if you guys are developers, you don't have to be an electronics expert, but if you are developers and if you understand, C and, maybe assembly if you want to, but mostly C, okay? I like assembly, it's good. It's more optimized for these kinds of devices. But if you have these devices, all these devices, you have electronics. Electronics can be programmed with C and sometimes other languages, and you can basically program all you want, the behavior you want for that. You just have to understand the interface to the hardware, and you can program that. Obviously, if you're an electronics expert, you can assemble the solution, right? But nowadays you can see a lot of videos, on YouTube and stuff like that, people that say, oh, I know IoT. They know nothing, okay? Because they tried some stuff that someone else did in another video, okay? But I know this happens, but still you get to learn something because the video actually works. You try it, it works as well, so it is okay. It's no problem. It's spreading the knowledge. It's actually good stuff. Okay, so if you are a developer or electronics expert, you have a good job here. And be aware of this, because this is the future and you're going to get a lot more of this coming along. So this might be your job in the next 2 or 3 years. Okay, so this could be good. Okay, so if you are a network expert, for instance, this is probably for you. Okay, so one of these. So you have to handle the network. Let's imagine this actually goes into the clouds, maybe Azure, maybe something else. You have the device here, you have the cloud there. There's a path to follow, right? You have to have wireless, you have to have cables, something like that. So a network expert is very necessary in one of these things. Additionally, there's one thing about this gateway that I didn't include here. It's on purpose, but there is something that came out at Builds, which is, I'm going to tell you about it later. And then you have another job for the rest of you. You can see this is electronics. You can see this is a bit of programming here in the middle. And then you see the end users here, normal users that know nothing about programming, that just want to see stuff, okay? Like, Power BI or something like that. They just want to see the information, okay? So what you have here, if you are the same as a developer, or if you are a DBA or a data scientist, okay, you can actually work on this side because the information flows from left to right. It's a lot of information, and you don't have to understand how you program the devices. You just have to have someone that sends the information to you, and then you need to process it, okay? You need to filter it, do the averages of temperatures, do the minimum, the max, do ifs, okay, if temperature very low, send the command back to increase the air conditioning or something like that. So you can do all of those things, okay? So you can do that part in green, okay? Everybody that knows programming can do that. Everybody that's a SQL, DBA can also do that. It's very much available. And that part in green is mostly what Azure has to offer. Okay? So, obviously you can find IoT everywhere, so you have everything. This Microsoft band still exists, technically, okay? So I'm not going to comment, you know this. I'm not going to comment, but it was a good example at the time. Okay. And there are some devices, you probably heard about this, I'm not sure if you... Has anyone tried one of these devices? 1, 2, 3, oh, quite a few, okay, good. So, you probably know this, so this is an Arduino board. It's not very powerful, but you can try some stuff like blinking the LEDs. Okay, no, it does work for some other purposes. I have used it for some projects, it's okay. If you need a bit more power, a Raspberry Pi or the equivalent, you have a lot of new boards now. I have a list in one of the slides after this. And if you need a board that actually has an operating system and it's complete, and you can actually program that in an easy way, like using Visual Studio or something else, you need something like a Raspberry Pi or any other board that runs Windows 10 IoT Core. Obviously, you can do this with Linux, okay? You have Raspbian, you have Pydora, you have all those distributions in Linux that you can try, okay? But this is a Azure session, so we have to talk about Windows. But I have to tell you, Windows 10 IoT Core has been around for more than a year, maybe 2. I'm not sure now, maybe 2 years. And I have to tell you, it has improved a lot. So hopefully in the coming years it will be even better. So let's hope. I mentioned some of this as well because these are important. So for instance, if you go and buy a solution already made, like for domotics, they all connect to each other, right? They're very easy because they're very expensive. They all connect to each other. It's like Macs, right? Macs and iPhones, they all connect to each other. But then people don't know what to do with it because they're very expensive. If they break, you can't do anything. You just have to go to the store and they give you a new one. And you're happy because it's really expensive. No problem. But I have a new one. Okay. And then you have... This is something really fun. So this is the size of a coin. You can actually wear it. You can put it in your clothes and connect wires to that and have sensors and everything. And this one is particularly interesting because it's very powerful. There are newer models than this one. This is ESP12, if I'm not mistaken. There are more powerful ones than this, but this is also very small. And this has wireless, has everything you can connect to it. You can use Node.js. You can use a lot of stuff with it. So you can program it if you want. And it's very, very advanced and very low energy. So if you put a battery in it, a small battery, it's probably going to last you more than a year, even working a lot. So it's small stuff and very practical. Okay, so enough about intelligent parts. Let's talk about dumb parts. So we need sensors, right? So we need to know what to sense. So sensors, you know, most obvious one, the one that comes with the LEDs, the button, right? So it's the simplest one. Okay. Then you have a keypad, that's the same, multiple buttons, but then you have some of these. How many, does anyone know what this is?
This is temperature of humidity.
Exactly, so this is DHT12, something like that, 11, 12, not sure which one it is. I just took it from the internet, I'm not sure exactly which one it is. But yes, it does measure temperature, it does measure humidity, so it's probably one of the most famous ones. Then we have this. What do you think this is? If you don't know the name in English, don't worry, just say the name in Polish and someone will translate. Don't worry about it. Okay, so this is scary because it has a lot of integrated circuits and all that. Yeah. So that thing in red on top is actually a light sensor, and that blue square thing is actually the regulator that says from a certain point, if there is too much light, he's going to activate some other stuff, maybe a light on top or something like that. So light sensor. Okay. This is probably a motion sensor. Okay, it looks like it anyway. Not sure. I took it from the internet. That's what you do nowadays, right? It's called internet for a reason. And that one is probably either a gas sensor or a fire alarm or something like that. Okay, can anyone tell what this is? You use it every day.
Door sensor? Door sensor?
Exactly. So if you have lifts, you go to lifts every day, right? You have those things that when you're in the door, it doesn't allow the door to close, right? So that's probably the most important thing for you not to get hurt. And obviously you have cell phones, and cell phones are a very advanced sensor, but you can do anything with them. You can do touch, you can do anything. So that's the extreme level of sensors. Okay. So for outputs, you have the obvious one. Everybody uses that, right? Different colors, you can choose. Okay. Okay. Can anyone tell me what this is?
Stepper motor.
Yes, it might be. Yes. Actually, when I downloaded it, it was garage door opener or something like that. But yes, that's also a good option because you use stepper motors a lot in IoT solutions. Yes. Okay. So this one, that's easy, right? Alarm kind of red thing that goes around that says something is wrong, run away, right? Something like that. Okay, something that tells you information, which is okay, text, that's nice, a bit more advanced. Nowadays we have touch screens, okay, so it's okay, but still works, very simple. And the exact same thing, that's not just a sensor, that's also a result, right? You can also see results on a cell phone and the screen in the back, something like that. So the cell phone is also a good example of this. Okay, and finally, can anyone tell me what this is? Relay, okay. So this is probably one of the most important pieces of actuators that exists, because if you have one of these, you can control anything, okay? So you have a small relay that connects to a bigger relay, and then a bigger relay, and then a bigger relay, and you can control, big motors from, factories and all that, and it all starts with that. You have a ton of those in your car, probably, okay? Car, bike, whatever. And those are important because basically if you have one of those devices in the back, you're not able to connect that to all the lights in here because they're just going to blow. So you have something like that which receives the signal that says, oh, turn on, and it's like a switch, right? So it turns on all the lights and it has much more power going on the place that gets switched. Okay, so what are the essentials that you need to get when you have an IoT solution? And hopefully you can see that in Bartek's session. You're going to be able to see some amazing stuff as well with it. So I put security first. You know why, right? You know about the car, that people were sitting in the car and someone hacked the car and the car started driving and stopping and everything. That is scary, isn't it? Try being in a lift or something like that and it's going up and down, up and down. That should be fun. If you're a kid, that's fun. If you're an adult, you're not that amused. Okay, so obviously use some sort of secure protocol, HTTPS. If you're not able to do HTTPS, try VPN, try some sort of gateway that allows you to be secure and you're not hackable, okay? IoT is not a perfect solution. It's like, last week's attack, okay, for SMB version 1. So people still used it because, okay, they had old machines, so they needed to use it, which is okay, but you could use it, but at the same time you have to be aware that you are using an insecure thing and you have to protect all the rest to make sure that insecure stuff did not reach that sensitive part, right? So the same with IoT. If you need to have devices like Arduinos, which clearly do not have, most of them, do not have computing power to do cryptographic stuff like HTTPS, at least make sure that when it reaches the internet, it's going encrypted through some gateway or something like that. Okay, or at least that the information that's going around does not affect you. Even if you just want information, oh, what's the temperature? Okay, so tomorrow someone's going to hack this and say the temperature is 100 degrees every day, and I'm like, that is bad, but what do I do with it? Okay, that's an error. I've been hacked. Nothing happened. No problem. I don't mind. But if that affects your life, like changing the air conditioning, that is a problem, right? Even if you spend more electricity than you want to, either way, it's going to affect you, and that would be a problem. Okay, has anyone heard of DNSSEC? Okay, so you have DNS queries, right? And all of those are unencrypted, and that is a problem because you can tamper with them. But one of the ways you can do is they are still unencrypted. There are solutions for that now. They're being developed. But one of the things you can do is you can sign the DNS replies and make sure that the DNS server that you want for, IoT.example.com or something like that goes to exactly the IP address you want to. And D verifies that certificate and all of that to make sure that's the signature, that's the correct signature. Okay, so that's important because otherwise your device is maybe going to try to connect to the attacker's device, right? That's going to be bad. So be careful with security. You have seen this week. The internet was a bit down because, people just needed to update stuff, right? That's all they needed to do. But they were very lazy. They blamed Microsoft for that, right? But it's not Microsoft's fault, right? Okay, because they were using a protocol which was obsolete more than 10 years ago. Okay, it's okay. So IPv6, does anyone here use IPv6? One person, okay, you should. Because IPv6 is faster, IPv6 has unlimited IP addresses, because technically if you do the math, you can have one IP address per every atom in the universe that we know of. Okay, so it's big. Okay, so you should really use IPv6 because if you have a lot of devices, you can have 1,000 devices in a field for agriculture, and you obviously can't assign an IP address for each. You can have private IP addresses, but if you can just do IPv6, you're going to save a lot on routing the stuff and that saves you a lot of energy on speeds and a lot of stuff. So it is good to use IPv6 much faster. Take a look at it. It is important. You should use it. Okay, so cloud service. Oh, by the way, Azure doesn't do IPv6. That is sad. Okay, but you can do IPv6, inside your network like Facebook does. So Facebook internally uses IPv6, and they are very much optimized using only IPv6. And then to the outside, they do need to use IPv4. But you can adapt, even on Azure, you can adapt that and have some gateways that use IPv6, like hammered in, and it works. So, cloud service, let's talk about this in a second. Okay, a few extras that you should use. Okay, so obviously if you're going to get all the sensor information, that's going to be a lot of information. You need to process it. There are big data solutions. You have, stuff like Hadoop and Spark, Storm, a lot of stuff like that. Azure has something called HD Insights that encapsulates all of that. And has anyone created a Hadoop cluster, installed Hadoop cluster? How long did it take you? Hadoop?
That was a few minutes, I think.
Really?
Yeah.
Oh no, but you used Azure, right? Oh no, I mean by hand. How many weeks would you take to configure it? So if you use Azure HD Insight, you just configure it, and it takes a few minutes, like you said, and it's done. But if you had to do it by hand, which is crazy, nobody ever does that. There is a cookbook for that, but no one does that. It takes like weeks, okay? So come on, this is easy. Just say how many ones you want, how many nodes you want, and it's done. It's much simpler. There's a wizard for that. That's what's good about Microsoft. That's a wizard for everything. Okay, blame Microsoft. There's a wizard for that. So just say blame Microsoft. Okay, so you have all of this. These are interesting. Although sometimes you might not need it. We'll see it in a second. Okay, machine learning. Has anyone tried machine learning? I don't mean specifically Azure, but any other machine learning. Great. Okay, so machine learning is very easy to try. You should really try it. Both on Azure, there are some really nice demos on Azure. Really easy to try it, and you should really try it. Okay, so let's move on to showing you one or two things. So this is going to happen to you in the near future, I would say. Okay, so not forget, Windows 10 actually has integrated All Join, which is a protocol which I'm not sure if it's going to be the best thing that's going to happen in the future, because you never know, right? But it's one of the things that they try to do to uniform communication between all these devices. So if the device is supported, really nice, let's try to use something that works together. And one of the things that it has is they actually communicate with each other and know what the other device allows. Oh, I can allow to be controlled, to control these lights. I have some sensors of information which gives you integer values, and you can read them. You can show them on a graph or something. So it automates a lot of things, and it's good to see. Okay, how many of you use Azure? Not enough people. Okay. Do you know it's free? You can use it for free. So you go to Azure.com. Yeah, you do it like this. You go to Azure.com and you say free accounts. Okay, and for a month you can use it. And after a month is gone, you try it again. Okay, so yeah, you can say you have to have a different email address. Yeah, that's it. It's being filmed. I didn't say this. Okay, so there is no excuse for you not to try some of these things. Okay, you can try Azure solutions, Azure demos. Some you can see in the next session as well, and you can try machine learning and all of that in HD Insight with the Hadoop and all of that. You can try that for free as many times as you want. Okay, so. Microsoft actually has some sample applications. This is not a final product. This is just a demonstration project you can try. So there is one called My Driving, which, as the name says, allows you to connect a cell phone with a computer, with a car, and registers information from a car. Do you guys have this ODB2? So you actually connect that dongle to a car, and you are able to see how fast it's going and all that. So all European cars from 1999, something like that, are obliged to include something like that. So you can get all that information. It's fun, and you should try it. And some people actually try to use it to see how fast they can go from 0 to 100. Okay. So, in all the presentation, I include a whole bunch of links. You can take a look at it if you want to. Okay, so the My Driving solution is a bit complicated. It has a lot of weird stuff in it. So I'm not going to show you this because it is a bit complicated and it's not current because some of these things have been changed. I'm going to show you a simple solution. So you have, if you go to AzureIoTsuite.com, you have 3 different examples, not just one like they had 1 year ago. They actually added 2 more. And you have, this is one of the examples. So this is, okay, so that's good. Okay. So you have an example where you get information from, a device, something like that. No matter how it's programmed, you get it from a device. And then you go into something called an IoT hub. This is something that's recent, has maybe 1.5 years old. And then you go to all the other stuff which I'm going to tell you about. And that is the magic here, okay? So I'm going to show you one by one what exactly these things do. So all the information, this is not a service, okay? So this is a demo only. If you want to use it, just adapt it. I know some people that have taken this demo exactly like it is, and they have adapted it slightly, and they have big companies that actually use it almost as it is, okay? So technically, it works. But obviously, if I was the one doing it, I would change it a lot. I would not start with this architecture. I would just use it as an example, okay? Because it's actually very expensive to do it like this. It's much weirder. You don't need all of this, obviously, okay? This is just a demo. Okay, so a lot of information. If you want to try with actual hardware, there are 2 examples here which are very fun to try, and they work exactly like that. You just have some hardware and you connect all the components and connect it to Azure, and it works. Okay, so this slide actually has one extra now. They have this example. Remote monitoring is just, I'm reading the information, I'm putting the information here, showing that on a Power BI graph. Predictive maintenance goes a bit further and tries to use machine learning to understand if something is wrong. And if something is wrong, he will try to alert you to say this is going to fail soon. So for instance, you have a lift. The lift goes up and down all the time. So after a while, if you begin to see some values which are measured going through higher or lower values than they are expected, the lift's still working, you can use it, no problem, but that's a good indicator that that's going to fail soon. So instead of that failing, people will be stranded there inside the elevator, you can just replace the part on your next maintenance before the part fails. And it's much cheaper for everyone. And the person doesn't get scared, okay? So you can go to this one. I have tried on my computer, but for some reason my accounts are crazy. Okay, this is probably Microsoft's fault. I know, right? So it's always Microsoft's fault. But my accounts are crazy, but Bartek's accounts actually work okay. So I will ask you. I'll ask him in a second to show me that in his computer. Okay, so basically what you do is you go in here, you select one of those, you go in here, you just give it the solution name because it has to be unique, okay? And then you choose which region. So you probably know about this from Azure. There are a lot of data centers spread around the world. You can choose one. You have to choose one, and then you have a subscription. You have to choose which subscription you want to. And then he's going to say he's going to install all of this automatically. So it's automatic. But be careful with this because it's not exactly the ones I mentioned here because they keep changing, which is good. They keep adapting the solution to show you a good demo. But this is the result, kind of the results, okay? So what you have here is you can actually have a sensor. These are virtual sensors, by the way, but you can connect physical sensors using that link that I've shown you before. And this information, which currently is random for random virtual devices, you can actually go up and down and see all the information. And if there is, for some reason, going over a certain value, which is programmed there, it can show you an alarm and inform you. Maybe send you an email if you want to. The solution only shows the information here. It registers that the alarm was raised and shows it here. But you can actually receive an email or any other kind of notice that you had that. So this is Power BI. maximum, minimum, average, all of this. You guys know SQL. It's obvious. Everybody knows how to do this. Okay. So, parts that it has. So it has a lot of parts. I'm going to show you one by one. But there is a problem with this, because if you install the solution just like that, the demo, it has a problem because it uses very expensive servers. Okay, so the first thing you need to do is go one by one. And for some of those, they actually say, oh, we need this with 2 servers, 2 nodes, and this and that, because it's more expensive, premium storage and all that. You don't need any of that. It's just a demo for you to try, right? So just go to each and every one of them, and if you see that spending a bit more than you expect, because you need the absolute minimum, just go there and reduce it. And I know I did, because I installed it, this was like a year ago or 2. I installed it here, and this is one day after, okay? So I spent maybe 60 euros just in one day, because I installed the solution and I didn't change it. So reduce it, and then you pay 2-3 euros at most per day, okay? So it's okay. And if you don't need it, just destroy the solution and recreate it whenever you want, because there is a wizard for that. Okay, so let's talk about each of the components individually. I'm going to start with storage. So you need places to store the information, and you store the information there. In this case, in this particular case, store the information there in 2 parts. One is the raw information, all the raw sensory information, and you also store there the aggregating information. So every X seconds he aggregates the information, minimum, maximum, whatever, and then he stores the information there as well. So you can query either one of them, which one is better for you. Okay. Then you have DocumentDB, which stores mainly all the configuration stuff for the database. For me, that is not a recommended solution, because DocumentDB, which is called now Cosmos DB, has some changes since build last week. And DocumentDB is a bit expensive, so you can replace that with storage, much cheaper. I don't work for Microsoft, I can tell you which part is cheaper, right? Okay, so for the dashboard, the part that you've seen with all the graphs, so it just uses a normal website, a normal web app, and then one of the things he does is he also has another web app to do the processing in the back, right? Something that he needs to do to verify stuff, to send emails, whatever he needs to do. That's something that you have in the back. I'm not going to talk about this, but obviously if you want to have logic apps, you've heard of logic apps, right? You all know logic apps from Azure. You can actually use logic apps with the output that you get from that generically, and do some stuff with it if you want to. Okay, Power BI is used for showing that information that you saw, and Bing Maps was used for the map. Okay, no problem. It works, and if you had a car which had location inside or something like that, you could map it there, which is okay. And then you have something which I would probably not use directly, depends on the solution, but they are using Azure Active Directory, which works pretty well, no problem. But if you have an IoT solution, there are sometimes different ways to do things, because you don't register that directly in the Active Directory. You don't have specific users in the Active Directory, but that is a good option if you want to do as well. If you don't want to control specifically your users and you want to use an Active Directory that already exists, so that is okay. If not, you just create a new one, and you probably don't use Active Directory. You use your own solution for that, maybe a database table or something like that. Okay, so IoT Hub is one of the most important features here. Everything else is, extra, you can add it. But the 2 most important ones, first of all, is IoT Hubs. So IoT Hubs is a direct relative, so to speak, from Event Hubs. The difference between the 2 is that Event Hubs is only unidirectional, and IoT Hubs goes both ways, okay? So IoT Hubs receives information from the device, and the processes the information and goes there. And if he needs to control the device for some reason, send it commands, make sure it's alive or something like that, he's actually able to receive commands this way and send the commands back to the device. It's not very difficult. Basically, it's An IoT hub is something like a first in, first out. Receives messages, sends messages. Just like that, okay? Bidirectional, which is great, and it has amazing limits. So Event Hubs is limited to 5,000 connections. I think that might have changed recently, but still the value is very low, while IoT Hubs is like millions, okay? So you can just connect it whatever you want. And obviously, if you connect many millions, you pay much more. But, the first limit, which is the cheapest, is still millions, so it's okay. Okay, so one of the most important things, and if you know SQL, you know select star from something, really simple query, right? If you know that, you know stream analytics, okay? Technically inside it's not a SQL stuff, but it looks like SQL, so that's the important part. So it has basically three parts. It has the input stuff that comes in here, the output stuff that goes away, and the middle stuff, which is the query, okay? So imagine the input is a table. Okay, you have a table, select star from table, right? And then you say into something, which is the output table, right? So think of this input and output not as as a stream, but maybe as a table. The difference is the tables do not end, okay? So if you have a sensor here, the sensor is going to show you information in 1,000 years, okay? So the table never ends, so the query never ends. So every time it receives rows, think of this as rows. Every time he receives rows, he processes the rows and he sends the rows back. Right? Make sense? Okay. So, it looks like SQL, not exactly SQL, but you have the from and the into to get the inputs and the outputs, which is okay. A lot of information here. You're going to see a lot more information in the next session about this. And this is a simple example. Select star from that input part, which is the sensor readings, timestamp by something. What is timestamp? So, I'm a sensor, okay? I send the information to the server. Let's try the second one. I sent some measurement to the server, and the server has a timestamp when you receive the information. So, that's the time we received. So, if it's fast enough, I can just use that one. Okay, but if for some reason I store the information on the device and send it once a day, I need the exact date and the exact time, right? So that's going to register in some field, and then I'm going to say timestamp by that field. So he's going to recognize that field is actually the time the sensor used the sample, right? And he's going to try all the functions which you're going to see next based on that. So for him, that is now the time field, okay? So there is these functions which I'm going to show you afterwards. Have you guys seen this? Okay, so think of this. You have select something from whatever, group by device or something. I want the max of that temperature or something like that. The table starts and ends. It's a limited table. But this is not a table. The inputs are not tables with the beginning and an end. They never end. Okay? So if they never end, there has to be a way to calculate things. Okay? So imagine this. You have 0, let's imagine this is 10 seconds. You have all these samples that go around at this particular time, right? So what he's going to do is he's going to do a tumbling window. What's a tumbling window? So every 10 seconds he's going to gather all the information that he has and he's going to put it all together. So if you want the average, it's the average of this value here. Okay? If you want the max, that's 6. If you want the minimum, that's 1. The average, you do the math. I'm not sure. Then you have 10 more seconds. Then you process these two. Average 7. This one's easy. And then you have this one, 10 more seconds. And then you have the averages every 10 seconds, which are okay. Because some measurements might be wrong for some error in terms of hardware, but the average for 10 seconds or 5 seconds is usually good value, right? So you can do this, but this is still not perfect because some other things need it differently. Oh, and by the way, group by, so this is the sensor because you want to do it sensor by sensor, makes sense, right? And you have a tumbling window, you say second because you want it could be second, it could be minutes, it could be hour, for instance, and 10 is the number of intervals that you have. But then you have a hopping window, the hopping window. Right? So the hopping window is kind of the same, but it overlaps. So if you have this 4, 6, and 2 samples, the measurements that you took, that's going to fit in this one, and you do the average. But since it's 5 seconds overlapping, he's going to do the average for this one as well. Okay? So he's going to repeat this, he's going to repeat well, not this, but he's going to repeat the 8 and the 7 again in this one because it overlaps. I want an average of 10 seconds, but I want that information every 5 seconds. Okay, so that could be useful for a fire alarm or something, temperature alarm or something like that. Okay, finally you have the sliding window. So the two before were actually very functional, very efficient. This one is not. So every sample that you receive, you're going to get a window from the last 10 seconds. That means he has to record the last 10 seconds of all possible samples. And you can see if I have 1,000 samples here, I would get 1,000 windows. Think of this as how much memory, how much CPU you're going to need to do the sliding window, because every sample has an aggregated value, right? How many samples it has, it can be 1, it can be 1,000,000, right? So just use this if you really need to use it, otherwise use one of the other two. And obviously the second one is is a general case for the first one, so it's not that much different. Okay, but this one is very CPU and memory consuming. Okay, so I'm just going to finish this, and hopefully you can show me one or two things. Okay, so there is something that came out last week in builds. So Azure IoT Edge, something new. So imagine you have a device. Imagine you have the cloud. You want to send the information there. 1,000 samples every minute or something like that. That's a lot of information. You don't need that. You just need the average, right? So what do? You program the device in C or assembly, and you say, oh, do the average every minute and send the information. That has a problem as well, because if you process that information in the device, and the device is running on batteries, that's going to spend a lot more energy, and the batteries don't last that long. So it's kind of a trade-off. You have to decide. But you can do that in the edge, okay? So if you have a gateway that receives the information from your device and then it sends it to the cloud, you can actually process that on the device. So think about this. You can process the information anywhere. You can process it on the device, somewhere along the way, or in the cloud. You can do it wherever you want to, okay? But this is one of the options that's new from Microsoft for you to try. It does require some hardware, specific hardware in the middle, but you can also try it. Okay. Mention this. I mentioned Windows 10 IoT Core just to mention some of the new stuff and some of the stuff that exists for a while, but it's important to mention. Nowadays, you can actually do secure boots. You can use BitLocker, kind of reduced version. You have Device Guard, which is also very good. Cortana. You can have Cortana in a Raspberry Pi now. Okay, so Cortana, she lives, okay. And if you do Windows Universal Applications, UWP, you can actually use those same applications in your Raspberry Pi. It's just as easy as that, okay. You just have to say, oh, send it to the Raspberry Pi. It's going to handle that. There are some limitations in terms of hardware, and in most cases that's just going to work. Okay, so Device Manager. Now you can manage your devices with something called Device Management, which, by the way, uses IoT hubs to control itself, which makes perfect sense. And then there are new boards. I mentioned I was going to show you a lot of boards, but you can try this on a normal computer. You know, a normal PC with Intel 8664 processor, so you can try that there if you want to. Okay, you don't need specific hardware to try this. Okay. Two more things. Cortana Intelligence Suite, you've heard of this, right? Everybody's talking about Cortana Intelligence Suite. It has nothing to do with Cortana, okay? Cortana is just one small thing. So they have machine learning. They have bot services. Bots are great, by the way. They bother you a lot, but they're great. Cognitive services, they allow you to understand stuff. So the idea here is you have a lot of sensory information. You read stuff, for instance, you can actually read stuff from Twitter or sentiment analysis, something like that. He's going to process that somehow, and he's going to associate that with people, associate that with actions, associate that with emotions, something like that. And then he's going to do something about it, right? He's going to decide, what do I do now? Based on that information, okay? People are not happy. Okay, send a smiley face. That works. Not. Okay. So, cognitive services. This page is huge. If you go to this page, there's a whole list. This is like 1/5 of all the services available, or even less. Okay? So, computer vision, you can see, you can identify stuff. Emotion. really happy, really upset. So you have a demo for that as well. Intelligent services. So Luis, you can actually understand what you're talking about based on the sentence. He analyzes the sentence and he understands the words placed correctly in the sentence, so they understand what you said. Okay, you can actually include Luis and other ones inside Raspberry Pis and talk to the Raspberry Pi and say, I want this, turn on the lights, I'm bored, okay, what do you want? Here's a song or something like that. You can actually program it to do that. He understands emotions, he understands every word that you say, so it's easy. It is available for English and it might be available for other languages as well, not sure which ones. Okay, so a lot of information here with cognitive services, and yeah. Okay, finally, just to mention this, just as anything else in IT, right? You need to be up to date with this stuff, right? Just go to user groups, like you have the Polish SQL Server user groups, and you have all user groups for specific things. In Portugal, we have 1,001 user groups for every possible technology, right? So nobody goes there, but we have 1,001. So just take a look at all the information, keep up to date. It's very difficult, but it is possible. Well, thank you. Thank you very much, everybody. Thank you. Oh, well, thank you to Bartek as well.